All right, class. Today we've been talking about resistors a little bit and finding equivalent resistance or effective resistance of different circuits and whether they be in series or parallel. So I'm going to show you an example where we have a little combination of series and parallel together. Pretty simple problem, but we just want to find the effective resistance of the circuit drawn above. Now, as you can see in the diagram, the 3 ohm and 2 ohm resistors are in parallel. These two resistors are in series with the 5 ohm resistor. So any electron flowing through the circuit can go through either the 3 or the 2 ohm resistor, but after that it has to go through the 5 ohm. Okay? So if we want to first figure out, well, we'll first figure out the equivalent resistance of the 2 in parallel. So to do that, we are going to say that 1 over equivalent resistance, and I'll just say P for, or pair for parallel, is just 1 over the resistance of the first plus 1 over the resistance of the second. Okay. So if we want to cross multiply, we will end up getting that equivalent in parallel is just resistance of the first times resistance of the second over resistance of the first plus second. Well, we can go back through that in class if you want to figure out how we got there, but I figure I'd save us a little bit of time. So we plug in our numbers. We get the resistance of the first is just 3 ohms times 2 ohms over the sum of the two, 3 ohms plus 2 ohms. Obviously that's going to give us 6 on top, 5 on the bottom, which gives us a parallel resistance of 1.2 ohms. Okay. So if we look at our original picture, that is actually combining those two. So what we're left with is we have a battery. I'm just going to give us an updated picture real quick. Connected to a 1.2 ohm resistor that then runs into a 5 ohm resistor and then back to the battery again. So we sort of combine those two. We got 1.2 ohm and we're left with 5 ohm. So to find the equivalent resistance of this, well, when they're in series, you just simply add them together. So to do that, we will just say RS for series is just the sum of the first one plus the second one, which gives us, well, the first one we just said was 1.2 ohms, and we add our 5 ohm, and then that means our total equivalent resistance, well, that's 6.2 ohms. So that's the equivalent resistance of the entire circuit.